For number 13, we're presented with the situation and asked whether we think it has a normal distribution or not. And so think of what it means to have a normal distribution. It means the mean, median, and mode are right in the middle of the distribution. And then it's symmetric. There's equal amounts of people that are above the mean, and there's equal amounts of people that are below the mean. Another thing to consider is how the value 0 would play into the distribution here. And for this example in the video, it's the amount of time adults spend watching television. So a lot of adults may hang out close to the average, and there could be some a little bit above and some a little bit below the average. So maybe you're thinking it could be close to a normal distribution, but when you start thinking about the value 0, there's probably a fair number of adults who watch no television throughout the week. So that's going to be a huge spike in the distribution all the way in the left-hand tail that throws off the symmetry, the bell shape, and all of that. In addition, there's probably a long right-hand tail because while most adults probably hang out close to the mean, some are going to be binge watchers or just watch television for hours and hours more than what the mean is. So there's going to be a far right-hand tail. There's also that spike at 0 for the adults that watch no television. So this situation would not have a normal distribution. To answer the remaining parts of the question, we're given a mean for the amount of time that adults watch television on a weekday. And we're given a standard deviation. And then we're told we're looking at a sample of, in this example, size 50, which is above that threshold of size 30, where once we're above size 30, we know from the central limit theorem that the sampling distribution is going to be approximately normal. So that's where we get that sampling distribution of the mean is going to be approximately normal. Our sample size is big enough. The mean of our sampling distribution is going to be the same as the population mean. That's always the case. And to solve for the standard deviation of our sampling distribution, take the population standard deviation and divide by the square root of our sample size. And make sure you're rounding to the number of decimal places that are specified in the problem. For part C, working with our sample of size 50, determining the probability that a random sample of size 50 has a mean that is in between two data values. So we can go into StatCrunch, question help StatCrunch, and go to our stat calculator, normal distribution. And make sure we're on the between, enter the mean for our sampling distribution of our mean, and then enter our standard deviation for that sampling distribution. Enter the two values you want to find the probability of being in between, and you can get that result. Part D is a look into how we can use the central limit theorem and sampling distributions to make inferences and find out more information about populations. So the gist of this problem is that when we consider everybody, the average amount of television watched is 2.25 hours. And the assumption is out there that people who use the internet a lot might be watching less television. So we're going to take a sample just from people who say they use the internet a lot. And then we're going to use statistics to see if there's any reason to justify that people who use the internet a lot watch less television. And so we gather our sample, and the mean from our sample comes out to 1.88. And so that is less than 2.25. But now we need to use statistics to see if it's far enough less that we can make any conclusions. And so we can jump into StatCrunch here, enter the mean for our sampling distribution, make sure we calculate the correct standard deviation by taking the population standard deviation, divide by the square root of the sample size listed in part D here. And then we can find the probability of getting a sample back with a mean of 1.88 or less. And the probability of that comes back at close to 10%. And so what that's saying is even if we included everyone in the world, not just the people who use the internet a lot, we would still get a sample with a sample mean of 1.88 hours about 10% of the time. That's not that unusual, 10%, 1 out of every 10 times. So there'd be no reason for us to think this is a very strange or unusual event. If the probability would have came back a lot smaller, if we were really far, even further out here in the tail, and it was a lot less likely to get the sample mean that we did, then we would conclude, well, something strange is going on here. This is a very unusual, very low probability. And we would say, well, the strange thing that we did was we only looked at internet users. So now we have reason to conclude that internet users actually watch less TV than people in general. But since we're at 10%, that's not a low enough or a strange enough probability for us to make any conclusions. And number 14, we begin looking at the sampling distribution of the proportion. And you'll want to look at that in the text. This little box here explains what we'll need for this problem. The shape of the sampling distribution of the proportion is going to be approximately normal as long as this holds true. So we would test that out here for the given situation. And so using Excel, if I do N, our sample size, times the population proportion, and then 1 minus the population proportion, which in this case is 0.6, I get a value back since that is greater than or equal to 10. And also since N is not bigger than 5% of our total population, so you could figure that out, 25,000 times 0.05. The largest sample size we could possibly get is 1250. 800 is less than that. Since we've met those two criteria, the being greater than or equal to 10 with that formula, and that the sample size N is no more than 5% of the population. Since we've met those criteria, we know the distribution of our proportion is approximately normal. For the next two parts of the problem, we'll look at the mean of the sample proportion and also the standard deviation of the sample proportion. And this box is again where you want to refer to. It tells us that the mean is going to be exactly the same as the population proportion. And then here's the formula we need to use for the standard deviation. So the mean's the quick one. It's going to be the same as what the population proportion is. And then let's use that formula. You take the square root, and on top of the square root, you do the population proportion times 1 minus that value. So in this case, 0.4 times 0.6. And then divide that by the sample size. So the sample size. So do all those calculations and take the square root of that entire result, and that gives you the standard deviation for your sampling distribution. For number 15, you want to start off by verifying that we can use the normal distribution for our sampling distribution. So do N times P times 1 minus P. Make sure that's greater than or equal to 10. And also that your sample size is not bigger than 5% of the population. The mean for your sampling distribution of the proportion is the same as the population proportion. And then you need to use this formula here to get the standard deviation of your sampling distribution. So I'll do that in Excel. We want the square root, and on top we do the population proportion multiplied by 1 minus that. So 1 minus 0.4 is 0.6. Take that entire result there and divide by your sample size, which in this case is 125. And when you do that, you get back the standard deviation. Make sure you have the correct number of decimal points that you round to, and enter that for your answer. And in part B here, it's asking what's the probability of in our sample having 55 or more individuals with this characteristic. And it says, it paraphrases that. That is, what's the probability of getting a proportion back of 0.44 or greater? And the reason it says that is we're looking for 55 or more in our sample. The sample size was 125. And so 55 out of 125 is the proportion 0.44. So we can come into StatCrunch, enter what our mean is and our standard deviation, and then find the probability of getting a value back of 0.44 or greater. The last part is asking about 40 or fewer. And so we need to calculate that on our own. Be 40 out of 125, that's 0.32. But here, in this case, the problem tells us that. So we would want 0.32, and the probability of getting that amount or fewer, and again, we can get that result right here. Now, if you've been paying close attention to B and C, you notice that the decimals are rounding off a little bit incorrectly here. These answers are more precise, but I'm going to show you how to make it match what they're getting here in your homework so that you can do that precisely. So what is going on is they're finding the Z value first and using that to get the final probability. So for example, for part C here, the probability of getting the sample proportion of 0.32 or less, I take that, subtract it from the mean, and divide by the standard deviation. That's giving me the Z value. And so typically when we work with Z values, we only round them to 2 decimal spots. And so this to 2 decimal spots is negative 1.83 as the Z value. And you're going to get the correct answer then, and I can come in here. Remember, with Z values, we can use 1 for the standard deviation, 0 for the mean, so we're looking at the standard normal curve here. And if I type in that Z value of negative 1.83, you get precisely the same answer that they have here for the solution in your math lab homework. So if you're getting these wrong because you're off by 1 decimal point at the end, use the Z value approach. Determine the Z value first, and then do what I just illustrated here in the video.